So, good evening, class. So, today we are going to discuss some of the important topics related to the physics, and there are very important topics are there which are related to the physics. And physics we had already seen during the course of covering the topic known as measurement. We had covered the various type of topics. First and foremost, we had seen what is the measurement. Measurement means to compare an unknown quantity with a known quantity. And during the course of finishing that topic, the measurement and its subsidiaries, we had seen the different type of units. We had seen the physical quantities as well as the fundamental quantities, the basic quantities. We had covered those topics and we had seen how we are deriving some of the important formulas, basically named as dimensional analysis. So we had finished the topic that is measurement. Now we are covering one of the most important topic in the physics, that is basically defined as the Newton's laws of motions. We had seen and we had checked also the various topics related to the measurement, and we had seen the application of motion there also, but we will be covering some of the important derivations related to the Newton's first law of motion, second law of motion, and third law of motion. First and foremost, we will see what is motion. Motion, the thing is that as the word suggests, motion, whenever any object changes its position with respect to the time, that is, that particular condition is known as the, then we can say that that particular object is in motion. Suppose if a particle is stationary at the point A and we are applying some amount of force to displace it to the point B. So we had changed its position from A to B. In that case, we can say that particular activity which we had done, it can be entitled as that the body had started from the rest to displace and from the rest thing to attain a new position, new you can say position on the line. That is the, you can say that the body had attained some motion. So motion, we can say whenever a body changes its position with respect to the time, that particular activity is entitled as a motion. So there are certain laws of motion. The laws are certain, the body of principles which which are accepted and recognized by the society for the proper administration of something. So in that case also, in the physics also, we are certain in every each and every particle in this universe is governed by certain laws, because laws are the basic principles. So motion is a kind of thing which is also governed by some of the laws, and that particular laws is entitled as Newton's first law of motion, second law of motion, and the third law of motion. As the word suggests, Newton's first law of motion suggests that a body continues to be in the state of rest and a body continues to be in the state of motion until and unless an external force is applied to change its state of rest or state of motion. So we can just in a more comprehensive manner, I can suggest that whenever a body is stationary at point A, and if we are applying any amount of force or any magnitude of force to change its position from point A to point B, now the body has attained some displacement or it had covered some distance. So we can say the body had traveled a particular distance from point A to point B. So it had changed its position literally. So we can say the body was in motion in that particular instant of time. So as the definition suggests, according to the Newton's first law of motion, a body continues to be in the state of rest or in the state of motion. Whatever will be the state, will be its initial state, if it continues to be in the state of rest or it continues to be in the state of motion, whenever we are applying the force, we are applying the force either to stop a body or to move a body. So a body continues to be in the state of rest or it continues to be in the state of motion until and unless an external force is applied to change its state. So we can say that we had applied a certain magnitude of force in order to bring certain amount of displacement. So in nutshell, we can say that force is an important parameter to resist any motion or to release the motion. So we can say that whenever a body is in stationary mode, we are applying the force to bring that particular body to the motion, or whenever a body is moving, we are applying a force opposite to the direction of the motion so as to stop that particular object. So, in a more comprehensive manner, we can say that if a body continues to be in the state of rest or in the state of motion, it will continues to be in the state of rest or motion until and unless an external force is applied so as to change its state. So, that is basically the Newton's first law of motion. And we had seen also Newton's first law of motion. Secondly, we will be seeing some of the important derivative related to the Newton's second law of motion. So Newton's second law of motion. In the case of second law, we had already seen, we had defined the motion also. Motion, if a body changes its position with respect to the time, time is an important parameter here and force is also an important parameter. Whenever any object changes its position with respect to the time, we can say that that particular object is in motion, because it changes its position with respect to the time. If it is not changing its position with respect to the time, then we can say that particular object is in rest mode, or it is in rest point. So we had seen what is the statement of the Newton's first law of motion, and we had also derived it comprehensively how we are understanding it. So Newton's first law of motion states that any object will be in the state of rest, it will continues to be in the state of rest, or any object will be in the state of motion, it will continues to be in the state of motion until and unless an external force is applied so as to change its state of rest or state of motion. That is basically the Newton's first law of motion. The Newton's second law of motion states that it is somewhat different than Newton as compared to the Newton's first law. Newton's second law states that the rate of change of it gives the basic idea about the definition of force, how we are deriving the force, because we had already seen in the case of Newton's first law, the force plays an important role, it plays a pivotal role, it plays an important role in deriving the equation. So whenever we are saying the Newton's second law, we can say the Newton's second law gives the idea of the force, or gives the definition of the force or the derivation of the force. We will see the derivation also, how we are deriving the force. So the Newton's second law states that the rate of change of linear momentum will be directly proportional to the force applied, and in this will affect the rate of change of linear momentum will occur in the direction of the applied force. So it will be in the same vector. It will not be in the opposite direction. If we are applying any force in the opposite direction, in the simpler manner, the general manner, we are saying so as to resist the motion, or to stop the motion, or to bring the object to the rest. But if we are using the word rate of change of linear momentum, so in that case it is latent, the word is there, the rate of change of linear momentum, it will be there with the help of force, and this effect will take place in the direction of the applied force. So we will be seeing here the Newton's second law. Statement is like that. Suppose the linear momentum, the first and foremost, we will just see what is the linear momentum. The linear momentum, it is this word is basically comprised of two words. It is basically linear and momentum, and it is a bifurcation of the two words, linear and momentum. Linear means any particle, it is continuing in the straight line. The word linear means the particle have to move on a straight line. And momentum means it is the product of mass and velocity. So we can say that by combining both the words, the linear momentum is a state of an object whenever any object moves along a straight line with having some mass and with the velocity. So that is basically the linear momentum. So in this case, we will be considering what is the rate. The rate is always defined with respect to the time. Rate is defined with respect to the time. So in this case also, we will be taking two cases. The first case will be the initial linear momentum, and second case will be the final linear momentum. The first case will be the initial linear momentum, and the second case will be the final linear momentum. So whenever comes the first case, that is the initial linear momentum, we will see, suppose the object was moving with the initial linear momentum. Suppose the object was moving with the initial linear momentum of mu. Understood? That is mass into velocity. The initial velocity we are considering as u, small u, and mass is m. Second case, it had moved somewhat. It had covered some distance. So we can say with the different type of velocity. Suppose its velocity had been increased to some extent. So in this case, the velocity will be m into v. But one thing we have to consider, or one thing we have to make a note, that mass will remain constant. So in this case, mu and mv, the rate of change of linear momentum will be, that is rate of change of linear momentum with respect to time. Anything, if we are considering any rate, it will be with respect to the time. The rate of change of linear momentum, it will be equal to mv minus mu by t. Understood? So rate of change of linear momentum, we are saying it is basically mv minus mu by t. That is the rate of change of linear momentum. So we have seen the equation of the straight line. Whenever we are considering, whenever it comes with respect to the motion, we had seen one equation, v is equal to u plus at. That is the famous equation of the straight line, v is equal to u plus at. So in this case also, we are seeing that is v minus u by t is equal to a. By changing the subject of formula, we can say that is v minus u by t is equal to a. So in this case also, if we are writing here rate of change of momentum, that is equal to m common v minus u by t. Understood? So we can take m as a common, because I had already stated the mass of the object will remain constant, the velocity will change. So it will be equal to m comes out of the bracket, within the bracket v minus u by t. So we can write here m into v minus u. I had already seen v minus u by t is a, and the rate of change of linear momentum is force. Whatever we are applying to change the momentum, that is force, that is equal to F. So we can say F is equal to m into a. So that is the derivation. We had seen, I already told you, whenever we are talking about the Newton's second law of motion, in that case the force plays a pivotal role. It plays a very vital and important role, and whenever we are seeing the Newton's second law of motion, it should come in our mind that it gives the definition of force. And the force is what? It is the rate of change of linear momentum. We had derived also how it is coming. First of all, we are considering the initial linear momentum, that is m into u. The final linear momentum, m into v. The mass remains constant. Rate always comes with respect to the time. So m into v minus u by t, that is equal to, and we have, with the help of the initial linear equation, v is equal to u plus at, we can derive here f is equal to ma. So in nutshell, we can say force is equal to mass into acceleration. That is the famous equation which we have derived here. So that gives the definition of Newton's second law of motion. The second law of motion states that the rate of change of linear momentum will be directly proportional to the force applied, and this force and this effect will take place in the direction of the applied force. So that is basically the Newton's second law of motion. Now we are switching over to the Newton's third law of motion, and it is also important, and it is very important also whenever we are solving the numerical problems related to the motion in the physics. So Newton's third law of motion, it is an important concept. We will be covering those concepts also. So Newton's third law of motion. Third is Newton's third law of motion. So in this case, we will be seeing here Newton's third law of motion. So in the case of Newton's third law of motion, the effect which we are creating, every action is equal to the reaction, and the action and reaction will not happen on the same object but on the same time. The statement which we have to consider here, every action means what? If action means what? If we are applying any force, that particular force will create a reaction, the same magnitude, but the action and reaction will not act on the same object. Both the force and the reaction force will not act on the same force, but they will act on the same time. The same time the action and reaction will come. So that is basically the comprehensive way of defining the Newton's third law of motion. The Newton's third law of motion states that every action has its equal and opposite reaction, and action and reaction will act on the same object, and The Newton's third law of motion states that every action has its equal and opposite reaction, and action and reaction does not act on the same object, but it will happen on the same time only. That is basically the comprehensive manner of defining the Newton's third law of motion. So these are basically the three laws which governs the motion. Now we will be seeing some of the important parameters associated with the Newton's laws of motion. The second case will be the rest. One is the motion, one part is the motion, and the second part is the rest. Motion is that whenever we are applying the force in the direction of the motion, then it is creating a motion, it is accelerating the object also. The rest, the rest is such a thing, rest is such a status of the object. Whenever any object is moving, and whenever we are applying any external force in order to oppose or restrict its motion or resist the motion of the object, that particular status, that particular condition of the object at that instant of time, if it comes to rest, or if the motion is zero, or unit velocity is zero, or speed is zero, then we can say the body had attained a status of rest. So that is basically the motion and rest. These two are very important parameters. The second case is that inertia of rest and inertia of motion. Second thing we have seen, that is motion. First we have seen motion. Second we have seen rest. So in the case of rest, I already stated, whenever we are applying any force in order to resist the motion or in order to oppose the motion of the object, so that the motion eventually comes to zero and the speed is zero or the velocity is zero, in that case the particle will remain stationary. So that particular condition is known as the rest. So third parameter is inertia of motion. Inertia of motion. Inertia of motion. And fourth is inertia of rest. Inertia of rest. So first of all, we will define the term inertia. Inertia, it is an important property of the object. It is the inherent property of the object to continue its state of motion or state of rest until and unless an external force is applied to change the state of rest or state of the motion. So basically, inertia is what? It is the inherent property of the object. It is the latent property of the object which allows the object to continue its state of rest or state of motion until and unless an external force is applied to change the state of rest or state of the motion. So if I am saying the statement, if an external force is applied to change the state of rest or state of motion, so it gives a definition of inertia of motion and inertia of rest. Inertia of motion states that if a body continues to be in the state of motion until and unless an external force is applied to change its state of motion, that is, if a opposite force is applied to change its state of motion to rest, then in that case we can say that inertia had changed. Inertia is the inherent property of the object. So inertia of motion means a body will continues to be in the state of motion until and unless an external force is applied to change its state of motion. Second is the inertia of rest. Inertia of rest means if a body continues to be in the state of rest until and unless an external force is applied to change its state of rest. So these two words are similar only, but they have a different meaning whenever we are defining both the words in the term of motion as well as rest. So these are some of the important parameters related to the motion, Newton's laws of motion, inertia of rest and inertia of motion. So we had covered some of the important definitions, derivations related to the motion. In the next class, we will be seeing some of the examples, the numerical examples, which will render more transparency and will make our concept more clear. So as of now, we will be seeing some of the examples pertaining to the complex numbers, because we have to finish this topic also, the complex numbers. So the complex numbers. As far as the complex number is concerned, we had seen various topics associated with the complex number, and we are on the verge of ending this particular topic, complex number. We will be seeing some of the examples, numerical examples, which will render more transparency in order to cover the topic, and it will make our concept more clear also. We will be seeing 2 or 3 examples, and we will wrap up this chapter, and we will be switching over to the quadratic equations in the next class. So we will be seeing some of the examples which will make our concept more clear. So we had seen here that we will be seeing some of the examples here. We had seen how to represent the complex number in the Argand plan, and we had seen how to represent the complex number in the vector form also, in the Cartesian form also, and now we will be seeing how to represent any complex number in the form of the polar form. In the form of the polar form, if you are taking one example, suppose question is 1 plus I. We have to represent this complex number in the form of the polar form. So in the case of the polar form, we are using cos theta plus I sin theta. That is the important topic. I is the iota here, and we will be, first and foremost, we will be seeing if we are writing here x plus iy, and we are just equating both the things. X is 1, I and y is also 1 here. So we are knowing that tan theta is equal to mod of y by x. That is the basic formula. So we are applying here 1 by 1, that is 1. Tan theta is equal to 1 or 10 pi by 4. So theta is equal to pi by 4. Theta is equal to pi by 4. Now we are seeing here the both the entities, the x and the y, both the entities are positive here. So we can say, we can make a you can say perception that these two quantities will be lying in the first quadrant. In the first quadrant, if we are drawing a diagram here, the first quadrant x is y plus plus positive, xy minus plus xy. In the third quadrant, both will be negative, and the fourth quadrant, will be y negative and x is the positive. So this is the basic Cartesian, the conventional signs which we are applying here. So according to this Cartesian diagram, we will be saying here that both the entities are positive. So these two quantities will be lying in the first quadrant. In the first quadrant, x and y will be positive. So whatever will be the theta, that will be the, you can say that will be the basic principal angle. So in this case, what is the argument? The argument will be under root 1 square plus 1 square, that is root 2. So we will be representing here modulus of z is equal to r under root, it is not root, it is cos theta plus I sin theta. Understood? So in this case, the r will be root 2 cos theta. The cos theta is pi by 4. So cos theta, which is 45 degree, 1 by root 2 plus I sin theta. I sin 45, 1 by root 2. So it is basically root 2, and by solving the equation 1 plus I. So it is will be 1 plus I. When we are solving the equation, it will be written as root 2 cos of pi by 4 plus I sin pi by 4. So we are writing here in the form of the polar form, it will be root 2 cos of pi by 4 plus I sin pi by 4. So we had represented this particular complex number 1 plus I into a polar form, that is root 2 cos pi by 4 plus I sin pi by 4. That is answer. So we had seen how we are writing any complex number or how we are representing any complex number in the polar form. So we had seen one example also here, and it is making our concept more clear. So secondly, we will be saying one more example that will make our concept more clear, and it will be easy also to understand also. So first and foremost, we will be seeing here some of the more examples here, and will make our concept more clear. Suppose we are using one complex number. We are using one complex number here, and it will make our concept more clear. Rationalization. Suppose 1 plus, the question is 1 plus 2i by 1 minus 3i. So that is the complex number, and in order to simplify this complex number, we are using the concept of rationalization. So we will be multiplying 1 plus 3i by above, and niche also 1 plus 3i. So it is 1 plus 2i into 1 plus 3i. By solving the denominator section, 1 square minus 9i square. That is 1 plus 3i plus 2i plus 2 plus 6i square. So 1 plus 1 minus 9 I square minus 1, and it is 5, it is 1 plus I square minus 1 to 1 minus 6, that is 5I minus 5. That is 6 into I square minus 1 minus 6 plus 1 minus 5, and 1 plus 9 10. So it is I by 2 minus 1 by 2. That is 1 by 2, I by 2 minus 1 by 2. That is the equation which we have found here. Now we will be using the basic formula tan theta is equal to y by x, mod of y by x. So in this case x is 1 by 2, y is minus 1 by 2. We are already seeing the conventional sign, the Cartesian signs. So x is positive and y is negative. In this case, and the x is positive and y negative, and we have seen also how we are using it. So it will be lying in the x is positive and y is negative. So it will be tan theta is equal to 1 and theta is equal to pi by 4. The first thing is that theta is equal to pi by 4. So, and the second case, we will be saying how to use that modulus, that is r is equal to under root y square plus x square. So, y square is 1 by 4 plus 1 by 4, that is r is equal to under root 4, 1 plus 1 2, r is equal to 1 by root 2. That is, we had seen r is equal to 1 by root 2. Now we will be substituting back substitution. By using the back substitution, we can write that is cos theta plus I sin theta. Understood? And we had seen here also that this particular equation, it is written here that it is lying here in the part of y is positive and x is negative. It is y is positive and x is negative. So we can say the y is positive and x is negative. So it lies in the second quadrant, and according to the second quadrant, so the principal angle theta is equal to, that is pi minus the angle. So pi minus, that is pi minus pi by 4. Pi minus pi by 4. That is pi minus pi minus pi by 4. It is, we will see pi minus pi by 4. It is 4 pi minus pi, 3 pi by 4. We can write here 1 by root 2 cos 3 pi by 4 plus I sin 3 pi by 4. So we had seen here how we had written, how we had substituted back, and how we had rationalized the term 1 plus 2i, 1 minus 3i to this particular term, and finally we had used the concept of the Cartesian coordinate by seeing the sign conventions, and we had checked and we had derived also how we are writing this particular term, this particular complex number in the form, the polar form, that is 1 by root 2 cos 3 pi by 4 plus I sin 3 pi by 4. So these two examples, in my opinion, it is giving more transparency, and it is enough also so as to solve other numerical concepts also. So we have seen here how we are solving the equations. So this is the basically the complex number, and so during the course of finishing the topic of the complex number, in the journey of the complex number, we had covered various topics, vivid topics we had seen, the concept of iota we had seen, the concept of addition, subtraction, multiplication, division, the property associated with the addition, subtraction, multiplication and division of the complex number, the conjugate of the complex number, the properties associated with the conjugate of the complex number we had seen, and we had derived also the various type of properties. We have seen the numericals associated with the concept, and in the last class, in today's class of the complex number, we had seen how to represent a particular complex number in the Fowler form, and in the next class, so if any issue will be there, just ping me, and I will try to resolve the queries within the shortest possible time. And in the next class, we will be covering the important topics such as quadratic equation, and it is important also. So till then, good night.